Hi, it's Richard here from Past That Science. A little topic today on phase current, line current, phase voltage, line voltage. So here's the first question. Calculate the value of phase voltage when the line voltage of a three-phase 4-wire supply is 410 volts. Okay, so I'm going to be doing this. I'm going to be writing the formula out. I'll be doing the calculation. Follow along, grab a pen and paper and follow along. It will be to your benefit. Lots of stuff, lots of information here. We've been asked to find the phase voltage. We've been given line voltage, and we're told the system is 3-line 4-wire. So if you were to ask yourself, well, is that star or is that delta? The answer is, well, it's star, because delta only has 3 wires. This is a 4-wire supply, so therefore it's got to be star. Now I like to visualize things, so here's a little drawing I've done for you. So we have our star connected system with the 4 wires. It's the 4-wire supply, so it means it's 3-line and neutral. And I've already put in the line voltage for you, 410 volts. And it's this voltage here we're trying to find, the phase voltage. So as a first sort of pointer, think about from the work that you do on site, you may kind of realize that you get 230 volts between line and neutral, and you will get 400 volts if it's a 3-phase supply. It's 400 volts between the 2 lines. So the phase voltage is lower than the line voltage, and that is one of the fundamental points for star. Phase voltage is lower than the line voltage, and if you think, well, 230 is the phase voltage, 400 is between the lines, so then we kind of know what ballpark figure that we need to be finding. So let's get into the calculation. Excuse the writing, I'm using a trackpad. It's not all that easy and it looks a little bit scrawny, but I'll try my best. So the formula that we're going to be using is, so it's the phase voltage that we're trying to find. VP is VL. Now, seeing that the phase voltage is the lower value, it means that I have to take VL and divide it by something. We're going to divide it by the square root of 3. That's the relationship between the two values, is square root of 3. Now then, let's put the values in. So it's 410 divided by the square root of 3. Let me grab thy trusty calculator and do the sum very, very quickly. See, we're doing this live. So it's 410 divided by 3 square rooted is, I get a handsomely, hope you did as well if you're following along, 236.71 volts. Underline your answer. When you're doing a written paper, always underline your answer, because if an assessor like me, sometimes if you have a page that's just full of writing, it's hard sometimes to see where the actual answer is. So if you underline it, or better still, if you double underline it, then all the better. Excuse the scrawny writing. A little sense check. Is the answer in the right ballpark figure? Well, as I explained earlier, of course, your line values, which are always higher. So if you had 410 volt line voltage, and even though it's normally 400 and your phase voltage is normally 230, well, 410 is slightly higher than 400, so expect the answer to be slightly higher than 230. I got 236. So that's all in the right ballpark. So here's the next question. A 3-phase 4-wire supply has a phase voltage of 239 volts AC. What would be the value of line voltage? So we're working back the other way. So of course the first giveaway thing there then is, of course, it's a 3-phase 4-wire supply, so that means it's star. And in all time honored tradition, if it's me, I tend to put it in a drawing. Only this time what we're given is the value of phase voltage, which is what you measure between line and neutral, and we're being asked to calculate the line voltage. As I said in the previous example, that the relationship between the two is square root of 3. So let's start off with the formula then, that your line voltage is the phase voltage, and because the line voltage now is going to be greater, then that means that we need to multiply that by the square root of 3. So then that's 239, as in the question, multiplied by the square root of 3. Let me get my trusty calculator out again. So 239 times square root of 3. So I make that, hopefully you're following along with your calculator and your pen and pencil, is what I would advise you to do. I make that 413.96 volts. Underline your answer, of course. Always, underline your answer, because for the assessor who's going to be marking your written paper, sometimes it's not clear. You know, if you've covered your paper in lots of calculations and stuff, it's not clear where the actual answer is sometimes. So underline your answer, better still double underline it. Is the answer that I've got in the right ballpark kind of figure? Well, yeah, it is, you know, because you've got phase voltage, which is 239, slightly above the normal 230, so I'd expect the line voltage to be slightly above 400. So 413.96 is about right. Let's go on to the last question. So here's the last question I'm going to take you through today. Voltage between two lines, the line voltage on a three-phase star connected system, at least this one says it's star, is measured at 415 volts with a phase current of 2.2 kA. So this is the first question we're dealing with current. Determine the line current and calculate the phase voltage. So we can do both of those without too much of an issue. So let's put it in a visual kind of form. So here is your line voltage, 415 volts. There is your phase current, what's flowing through each element, 2.2 kA. So shall we do the easy one first? The way of determining the phase current the line current, is actually quite easy, because your line current, I don't know why that's in red, is the same as phase current. So your answer to this question is 2.2 kA. How does that work out? Well, they've somehow measured the current here. So if they used an ammeter, it would go into that line there. Now don't forget, like with a circuit like this, and it's the same with series resistances, it doesn't matter where you measure the current to this point, the current is always going to be the same value. Because if I inserted an ammeter at this point, what current would it give me? 2.2 K. So would it make any difference if the ammeter was here, or here, or here, or here, or here, or here? You'd get 2.2 Ka. So with a star connected system, the currents are always the same. The line current and the phase current are always equal. So that's the equal part, the easy part of the question. So let me just scrub that off, and then we can deal with the voltage part of the question. And let me put the pen in blue, which would be nice. So let's deal with the phase voltage. So we've had a phase voltage one already. So your phase voltage is equal to the line voltage divided by square root of 3. So the line voltage this time is 415 volts. It's old three-phase volts, that is, divided by square root of 3. And actually, do you know, I don't actually need to use the calculator. But I'm going to use the calculator. Only because I've done this calculation 5 million times. 415. Let's try it again. 415 divided by the square root of 3 comes out as a princely. Let's don't like this trackpad. 239.6 volts. Underline it. Is that in the right ballpark? Well, yes, it is, because note that the line voltages are higher. We're a little bit more than the normal 400 volts. We're on 415, so we'd expect the phase voltage to be a little bit more than 230, and that's why I got 239. So I'm quite happy that that question's in the right ballpark. Okay. Thanks for watching. Now go pass that science exam.